Good afternoon, everybody. Thank you for the introduction. Thank you for the invitation also. Qualitas Remos, this is a small company working from Spain, Portugal, and Morocco. So we have offices in those three countries. And our areas of expertise, mainly two. One is ocean observing, mainly by HF radar technologies, and added value applications around it. So we are very interested in working on added value around ocean products. Second area of expertise, we are working on development of applications and IT solutions. So for instance, the marine information system of Puertos del Estado, the Portus, was started for the 3-year period in a public-private cooperation with our company. Here you can see in this image how the Livorno HF radar site looks like, which is the Naval Academy. I'll speak a couple of times in my talk about this. Well, points that I would like to stress. Sea, very close, not very much known. Why data if you have models? So this is a question that is asked to us every now and again. Applications, some reflections about search and rescue, some reflections about the existing infrastructure, and ideas on how products related to modeling and data are enriching each another, and also some challenges and ideas for the future. Well, the sea. Here we can see an eddy, 150 kilometers long, in front of California. It was not discovered until the wide-scale observations were done, and it happens that it comes sometimes for summer and stays there for 1 or 2 weeks, and it changes completely the circulation along the coast with important impact on fisheries and everything. This is not California, so this is Tuscany, Capraia Island. This was a couple of days ago. So this is an eddy which is 50 kilometers wide. Well, it has something to do with trash, with the eventual floating debris. And we can see, looking at the scale of the area that has now real-time data, plenty of possibilities to work on models combined with data. Our company, we very much appreciate the free and easy access to data of Copernicus. So we have 5 areas selected in the European seas where we are taking every morning machine-to-machine information from the surface layer of currents, and we are comparing hourly data for measured and modeled information. And this is something we are doing in a standard way in 5 places, just to try to learn how models and data look to another, and how we can help improve our data quality, and also how models, especially high-resolution models, can improve by having additional data. Why data? Well, this was a question that was asked by the Spanish Director of Merchant Marine before doing the first investment into HF radar to Enrique Álvarez Fanjul of Puertos del Estado. And his answer was very expressive. If I fall into the water, please use data if you have them. Then he gave additional explanations. But this is a slide that was presented by the Spanish Coast Guard at a meeting in southern Portugal, speaking about a true exercise in the Alboran Sea. So they run 4 trajectory forecasts, and they were very different. It's a very complex area, so it does not mean that any of the model is wrong. It means the variability is very high there. And it would be nice to have data. Well, history of oil spills, this will never happen again, but it happened many times in the past. So also in the Mediterranean. Application case, search and rescue. United States is working with this kind of wide-scale technologies for a long time of period, and they have quantified how many lives they save every year thanks to having data. It's not that they use the data, they use data that are ingested into models. So they work with models which produce a better performance when using data. Southern Europe, plenty of work to do there. So I could see opportunities for this kind of activities. Some examples taken from the US Coast Guard, and they compare their models that don't use HF radar with their models which ingest HF radar. And they can see after 96 hours, search areas can get reduced to 1/3. So they speak about how many lives they save, and they speak also about reduction in search area, which is money. Well, now to our Mediterranean. There are plenty of radars in the Mediterranean already, and most of them in really key locations. So we were hearing about the Ibiza Channel, but we can see Malta Channel, Gibraltar Strait, and plenty of very interesting areas. Our company has been involved in many of these deployments. So 23 out of those radars are related to the US manufacturer Coda Ocean Sensors, and we are partnering with them in the EMEA region. A very nice case where a group, Puertos del Estado, that is operating radars for a long time and working on modeling for a long time, is trying to optimize their models, which means also circulation models and trajectory forecast for the Coast Guard, based on this kind of data. So I'm presenting a work that has been carried out by the group of Enrique Alvarez Fanjul. Javier Soto is the principal researcher here. Gibraltar Strait, very interesting. So 2 years ago, 500 search and rescue missions in 1 year. This is pretty normal. Gibraltar Strait has now, for longer than 2 years, maybe almost 3 years, a high-resolution HF radar system. Puertos del Estado has been working with our collaboration on its validation. In parallel, high-resolution models that were nested in the Copernicus models have been elaborated. And a long-term analysis of time series of modeled and also measured data has been carried out. Monthly mean fields, longer period statistical analysis, rotary spectra, tidal constituents. Very interesting is there are 3 principal modes of circulation here. And in one of those modes, the wind-induced component, the models are not able to capture the wind changes. So the models up to now, they show there's a surface circulation in Gibraltar always going into the Mediterranean. And we know this is not true. Well, as part of this model data intercomparison, Puertos del Estado quantified what the agreement was in each of those 3 models between data and models. Conclusion of this analysis was we need to do something with HF radar that helps us predict the future, improving our present models. how can we integrate in our models the influence of the wind that we know exists and that HF radar captures. So the approach of Puertos del Estado, and this is something I would say we could carry to every other place where we have radars, is models have a very nice and homogeneous picture in space and time. Observations, they reveal some drawbacks or limitations, and they also can incorporate subtle characteristics that we are interested in. So based on this idea, Puertos del Estado has thought for a while means for a couple of years, how to introduce HF radar advantages or strengths into Gibraltar. And their idea, which I think is very much smart, is they're building right now a data fusion product. So in the area where both sets of data have a good correlation, they are creating a data fusion product based on a dynamical sponge layer. So in the middle of the measured area, they are increasing the weight of the data, and towards the border regions, they're giving less worth to the data and more to the model. This essentially simple idea has brought the model, which is now in evaluation, a follow-up model, to be able to see that the surface circulation points towards the Mediterranean, towards the Atlantic at some point, in some points in time. So the effect of having water flowing or people sitting in the water moving towards the Atlantic is now captured by the model, thanks to this data fusion approach. So we are saying at the same time, we need models, and we can take advantage of data to improve the models. Well, the reason why we are looking at models regularly is trying to learn and generate ideas on how data and models could help another. So this morning, I was looking at an eddy staying in the Malta channel, which was not represented by the models. So I can see a task there. And by identifying tasks, we will look for solutions to work on. I'll speak about the Corsica Strait, which is the closest radar now operational to this place. Very nice is many times we have full coverage of this area by two stations, one located in Livorno and one in San Vincenzo. Regione Toscana started this project inside Sycomar. Consorcio Lama is operating those radars. Well, in relation to observations, one topic that we need to address, one question is, what's the scale we should work on? So here we have a nice scale because we are covering a long part of the time the whole channel. But if we want to be useful to groups like the Coast Guard or to a wider community, maybe the scale should be a little bit wider to have impact on our societies. So I can see Ligurian Sea as a unit. We could speak about wider units, but having the same methodologies on a wide scale is certainly advantageous. There are ideas of extending inside the same Sycomar framework the collaboration to Corsica, maybe south of Elba, or to other places along the Ligurian Sea. The Livorno site I was speaking about, it's an ideal place, Naval Academy, also very interested in this kind of technologies. It's an airport, a helicopter landing place, so they need to be ready to put everything down inside minutes when they need it, but it's possible here. The other side, San Vincenzo Harbor, We can see the antenna on top of the marina, in between the masts of the ships. Challenges and ideas for the future. We would need to think about the scale of the appropriate scale of observatories. I can see Interreg initiatives as crucial, so we cannot work at local scale, but certainly across countries. This is very important. Validation of whatever we do, it takes time. But after that, the real important activity is to add value. So observing in itself has no value. So the added value applications is where we can see the field. And I can see, by looking at, in a standard way, at modeled and measured data, there are certainly ways to improve trajectory models. We are ourselves working with different models. But in every place, possibly, the way of ingesting the data may be different also. And we can see there a very interesting field in relation to use of beaches, to clean waters, search and rescue planning of water, sewage plant management. So we have seen in many beaches releasing water at the wrong time and making our beaches dirty. And another application I would like to speak about is vessel detection and vessel tracking tools. We can think about military applications, but I want to speak about civilian applications. So we're speaking about releases, uncontrolled releases that happen rather often and that are giving into the water more oil, for instance, than accidents. And by having additional tools that can observe positions of vessels, we would have capabilities to find, by backtracking methodologies, but to find offenders. Livorno, for us, a very beloved place. There is an institute there, CSS ITE, which is working with us on developing and validating vessel detection capability associated with HFR. So on the same tool, we have the capability of observing ocean variables and also of detecting ships, still in development, but very promising. In this image, which is stationary, you can see a ferry that started in Capraia, which is 63 kilometers away from Livorno, from the Livorno radar, moving towards Gorgona, which was its destiny. And this would be all from our end. So the message is, thank you very much for giving for free data. This gives us the opportunity to participate in the whole game. I don't see private and public as both sides, two different camps. I can see private companies have something that is, if they do something useful, they will be called. If they don't do something useful, they will be left aside. So that's our life and problem, and we are happy with it. And we would very much like to participate with our experience and your ideas also. Thank you.